Sorry about that, I had to make a second video. So, here, let's plot this one. So there's our plot, just connect those points. And you can always kind of safely assume, as long as there are no transformations in here, you're going to be at your x equals 0 line as the asymptote. So we know x equals 0. X-intercept is still 1, 0. We can see here, crossing the x-axis at 1, 0. Domain, what x values do I have? Well, x is bigger than 0. I'm not anywhere over here. I'm not using the left side of the graph. I'm only using the points where x is bigger than 0. And the range is y, such that y is all real numbers. Now, when is my y value approaching 0? Or not 0, approaching infinity? When am I getting very big y values? That's as my x-axis gets close to 0. And then as x gets very big, my y values are getting smaller and smaller. Let's do... we've got 4 more. Let's do the first 2. Let's do the first 3, and then I'll leave you guys to do your homework. So, log base 4 of x minus 1. We're just going to graph the log base 4 of x for right now, and then we'll shift things down. So, again, you can think of this as log base 4 of x equals y. So log base 4 of 1 equals what? Or 4 to what power gets me 1? Well, that's 0. 4 to the 0 gets me 1. Anything to the 0 power gets me 1. And then we'll do 4. And we can do 16. We could do 1/4 if we really wanted to. So 4 to what power gets me 1? It's 1. 4 to what power gets me 16? That's 2. 4 to what power gets me 1/4? Well, if I flipped my fraction from 4/1 to 1/4, it's negative. And then 4 to what power gets me 4? Just 1. So let's graph this. Let's make some very small dots here. So 1, 0. 2, 3, 4, 1. 16, 2 would be like way out here. And then 1/4 is negative 1. Now let's shift all of these up. Or not up. Let's shift all of these. And what kind of shift is happening here? Well, it's inside the parentheses, or it's with x. So you got to think opposite. So instead of left 1, we'll shift all of these right 1. And we can make some big dots here. And you can kind of assume that if this was our typical asymptote, right there, if I shifted everything right 1, then my new asymptote must be here. So my graph must look like this, more or less. All right, so let's talk about domain. What x values do I have? Well, I've got x. And now x is bigger than what? So what x values am I bigger than? That's 1 right there. And the range y, all real numbers. So we're pretty much only going to be working with all real numbers here. And now let's see, when is my graph approaching infinity? When is it getting higher and higher up that y-axis? Well, that's as x approaches infinity. And now, when is it going to negative infinity? Well, that's as x approaches my asymptote of 1. To find your y-intercept, or not y-intercept, your x-intercept rather, you can plug in 0 for y, and solve, or you can just look at your graph here. That would be 2, 0. And that asymptote x equals 1. Let's do 2 more, then we'll call it a day. So first of all, what transformations, what shift or shifts are happening here? Well, this is not in parentheses, so be very careful about that. No parentheses here. So you can treat this -2 like it's outside parentheses. So it's down 2. And again, we'll do our xy table. Log base 3 of x. We'll start with 1. So log base 3 of 1 equals y, or 3 to what power gets me 1, always going to be 0. And then we'll do some powers at 3. So, let's do 3 and 9. You could do 1/3 if you really wanted to. So 3 to what power is 3? It's 1. 3 to the second is 9. If you want to do 1/3 and 1/9, that would work as well. But again, we haven't done our transformation yet. So we're just going to make some small dots. And now, how do we have to shift all of these points? We've got to shift them down 2. Let's take these points and shift them down 2 and make some much larger dots. And now let's check this out. What does my new graph look like? And, right here, you have to understand that's not really supposed to be touching the shouldn't really be touching the axis there, so let's make that a little bit better representation. Why did that not work? So let's kind of thin that out. There we go. All right, that's a little bit better representation. Now the domain, x, we didn't shift left or right, so x is bigger than 0. Y is still all real numbers. When is my graph going toward infinity? When is it getting higher up that y-axis? That's as x goes to infinity. And when is my graph approaching negative infinity? When is it going down forever? That's as x gets closer and closer to 0. X-intercept. Well, let's look at our blue graph here. When am I crossing that x-axis? Right here at 9, 0. And that asymptote is still x equals 0. So why don't you guys try your last two here. Remember, in the parentheses, it's going to be opposite. Outside the parentheses is the same. And for your XY table, you just want to graph this part first and then do the transformation. So number 6, we would just do this part first and then do the transformation of right 1